Hi, good evening all. Welcome back to our channel. So today we are going to derive the condition for reciprocity and symmetry in Y parameter model. Let's try to see what kind of output we are going to get. So the Y parameter matrix is Y11, Y12, Y21 as well as Y22. So this is nothing but the Y parameter matrix. So now if you see the diagonal elements, okay, so the condition for symmetry in Y parameter model is y11 is equal to y22. The condition for reciprocity is equal to y12 is equal to y21. This is very simple to solve. So before finding this, we need to find out the expressions. Okay, so we have the expression I1 I2 is equal to y11 y12 y21 y22 multiplied with v1 v2. So therefore I1 is equal to y11 v1 plus y12 v2. Second equation is I2 is equal to y21 v1 plus y22 v2. What we need to do here is, so we want to take a y parameter two port network. As already I told, we want to excite with a voltage of v1 and current flowing into the branch is I1. And so previously the current used to go like this is nothing but entering, which is nothing but plus I2. Now the current will flow in opposite direction. Okay, so when the current is flowing in opposite direction, this will be automatically I2. How current will flow here? Only when we short circuit this. So that is v1 is equal to 0. So here also, in finding out the reciprocal parameter, we want to find out the ratio of response to the excitation. So what is the response means output. So we need to find out the ratio of I2 to the excitation is V1. So what we need to substitute here is, so in the place of I1, sorry, in the place of I2, we have to write down it as minus I2 and substitute V1 is equal to 0 in these equations. So here, see here, so I1 is as it is, I1 is equal to y1 v1 is 0, automatically 0. So this is y12 v2. And when you see this equation, so current is minus I2, that is equal to v1 is 0 plus y22 v2. So from this expression, we require the ratio of I2 by v1. Where is that expression I2 by v1? So we need to find out the I2 by v1. So here you can see, here we have I2 by v1 we want to express. So here we are going to get this, sorry, this is v2 is 0. Whenever v2 is 0 here, automatically, sorry, this output port is 0, no? So automatically this is I1 is equal to y11 v1 plus 0. Here it is minus I2, and here we are having v1 is, sorry, v2 is 0. So we are going to get here y21 v1. We require the ratio of I2 by v1. Here itself the ratio is there. This is minus I2 by v1 is equal to y21. So we have been find the response to the excitation as this value. So we got the value of y21. And now what we are going to do here is the same network, the y-port parameters we are taking. Previously we are exciting at input side. Now we are going to excite at output side with an voltage of V2. The current flowing into the branch is I2, and so here we are having the input terminals. So current used generally go as I1, but now we are taking the current is leaving. Therefore, the current I can write down it as I1. This current has to flow means what I have to perform is V1 is equal to 0. I need to perform. Now substitute the values as V1 is equal to 0, as well as in the place of I1 write down it as minus I1 in these original expressions. See here, I1 we have to write down it as minus I1 is equal to V1 is equal to 0 plus Y1 to V2. In this second equation, so I1 is as it is. This is V1 is equal to 0 plus here we are going to get Y2 to V2. Okay. So only here we get the change. So already I told we require here response to the excitation. What is the response? We need to find out the ratio of I1 divided by V2. So identify the equation. So this I can write down as minus I1 by V2 is equal to Y12. So compare this equation with second equation. So comparing the response to the excitation, I mean output current to the input voltage, what would be the value of admittance by comparing first equation and second equation is, so when you compare both the equations, automatically will get a relation y12 is equal to y21 is the condition for reciprocity in y parameter model. So already we told. So this is the condition for reciprocity for y parameter model. Next, we need to find out the symmetry for y parameter model. So what are the standard equations we have is these two equations. In these two equations, what we require is the values of y11 and the values of y22. What to do here? So how to obtain the value of y11? By making this term as 0. What is this term as 0 is making v2 equal to 0 means output port is short circuited. So when output port is short circuited, this term becomes 0. Therefore, y11 is equal to I1 by V1. And in this expression, I require y22. So y22 value I will be obtaining by making V1 is equal to 0. What is the meaning of V1 is equal to 0? Is input port is short circuited, automatically this term becomes 0. Therefore, this is nothing but I2 divided by V2. When you compare this current, I mean response to the excitation, the both input side and output side, the condition for symmetry is y11 is equal to y22. So this is the condition for symmetry in y parameter model. Very simple to understand, no need to worry a lot. So the diagonal values are equal is the condition for symmetry, we already derived it. The condition for reciprocity is if you apply the voltage at input port and find the current at output port. So apply the voltage at output port and find the current at input port means we can reciprocal the input and output ports, the admittance remains same. That's what the meaning y12 is equal to y21, and this is symmetrical. Symmetrical means, so if you take a square paper, okay, you fold it to halves. The area occupied by the first half is equal to the area occupied by the second half, then I can call this as an asymmetrical paper. The same is also done here. So successfully we got the condition for reciprocity and condition for symmetry. If you feel the content is useful, please like to the video. Please share with your friends. If you have any doubts, let me know in comment section. And if you're watching for the first time, subscribe to the channel, which is an free channel for the benefit of students. So hope we'll meet in the next video. Thank you for watching. Yours obediently, Ram.